Hello, my name is Trevor Farnsworth. This presentation is about a subject known as Procedural Content Generation, or PCG for short. So what is PCG? The answer is in the name, but it may still be hard to grasp. Procedural Content Generation uses mathematical formulas and systematical processes to generate content for games, visualizations, and other forms of digital media. In this presentation, I generated the slides using this method. Another important definition is the term algorithm. An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. Skills in PCG are increasingly more valuable these days. The most common use of this science is in game development. Probably the best-known game that uses this technique is Minecraft, which uses PCG to generate the landscape as you travel in the game. The genre most affected by PCG is the space simulator genre. As already mentioned, procedural content generation is useful in visualizations. Many presentations may involve 3D models that need realistic textures. One of the first uses of procedural content generation was in movies, in which fictional environments had to be made as realistic as possible. It would take much time and money to create, photograph, and attach images to 3D models in a movie. Instead, PCG is capable of creating three-dimensional textures, which can be assigned to 3D models. Add some special rendering technology, and the scenes come to life. There are many different types of content that can be affected by procedural generation. One of the simplest visible uses that procedural generation can be applied to is textures. The slides of this presentation are examples of this. Also, as I said earlier, Minecraft uses PCG to generate landscapes. Many other games also have level generators. However, the true capabilities of procedural generation are exposed in space simulator games. In many of these games, the stars and nebulae are procedurally generated. In addition, procedural generation may be applied to the planets, ships, stations, and even economies in the game, so that no two places are alike. This means that 3D models can be generated. The data produced by a procedural process can also be used for other things, such as the economies mentioned. At the core of each region would be an algorithm that says where to place the planets and stations, and other important information. Data can also be used for other things, though, like an AI character's traits, and even names for the planets and ships. Within each category of content that can be generated, there are different methods that can be used to create different effects. The type of content I am most familiar with, and that I have examples for, is texture generation. In this example, the color intensities are determined directly from the output of the algorithm. In this example, the result of the algorithm is added to the sum of the color intensities of the pixels to the left and above the pixel in question. This example uses the same method as the previous one, but it uses pi to prevent the pattern from repeating. In addition, a z-axis can be simulated. This is best shown through videos. Images could probably be generated radially, where the image is drawn from the center out. Also, the distance from the current pixel being generated and another point could be used to deliberately affect the outcome. There are several attributes of procedural content generation that make it so valuable, so interesting to study, and so complicated to truly take advantage of it. Here are a few of those. First of all, the textures in this program actually extend infinitely in all two-dimensional directions. Had I included a third dimension, as many programmers do, it would extend infinitely in all three-dimensional directions. As defined earlier, every input has an output. The inputs to these textures are the x and y coordinates. Only a small range of these coordinates are shown, but the color intensities for any point on the two-dimensional plane could be calculated. In addition, many algorithms take another input called a seed. This input is incorporated into the program in such a way that if it is changed, a new pattern will generate. Therefore, one well-built algorithm can have an infinite number of possible outcomes depending on the seed. Another term for the algorithms used in procedural content generation is a pseudo-random number generator. The word pseudo means fake. This means that the outputs produced by the algorithm appear random. However, it is not random. The benefits of a pseudo-random number generator over a random number generator is that a pseudo-random number generator will produce the same value for each input. This causes an entire game world that extends infinitely in all directions to always look the same. If it used a random number generator, a mountain that was a certain distance from a city will not be there the next time you go to visit it. What follows is a technical explanation of procedural content generation. A method commonly used by computer programmers is the IPO chart. or input, processing, output chart. For these slide backgrounds, the inputs are the x and y coordinates of the canvas, and sometimes a seed. The processing stage takes in these inputs and applies a mathematical formula to them. Trigonometric functions are very useful here because functions such as sine and cosine repeat indefinitely, and the outputs can always be used. For example, the engine might add the sine of the x-coordinate and the sine of the y-coordinate. This produces the output. In this example, the output would be between -2 and 2. However, for these outputs to be any good, they have to be used by the engine as a parameter for some form of content. Here is the texture generated by the aforementioned IPO system. The output is converted to a value between 0 and 255, holding the same proportions to the minimum and maximum as in the original output. The number ranging from 0 to 255 is used as the red percentage in the red, green, blue color definition. So how do we incorporate other methods of texture generation into this? As previously mentioned, other textures I have generated also use the values of the pixels to the left and above the pixel being generated. In computer programming, it is possible to get the fill values of certain pixels on the screen. All you need to do is get the fill values of the reference pixels and add them together. Divide the result by 2 so the value isn't so large. Then run the algorithm and add the result. This value may be negative, causing the output of the equation to be smaller than the reference points, or it could be larger. Some examples of textures generated with this method are shown. Most of the time, game developers do not want repeating patterns. There is a variety of ways to do this, but the one I have implemented uses pi, a non-terminating, non-repeating decimal, to prevent a pattern from occurring. Other methods use modulus, or returning the remainder of a division problem, in a way that the outputs will not repeat until no more values are needed. Another important thing to consider is what the output will look like. Usually, a developer is trying to achieve a specific result, which will require a particular algorithm. A good example is generating stars using procedural content generation. The key to this task is the tangent function used in trigonometry. The graph of this function extends infinitely upward along each vertical asymptote. When combined with other trigonometric functions, a seemingly unorganized or a remarkably interesting and organized star field can be produced. Here's an example of a procedurally generated star field. The only problem with this is the line of symmetry where x equals y, where the top left corner is 0, 0, and y becomes larger the further down the canvas you go. On this note, I would like to present the highlight of my experience thus far with procedural content generation. Here is a pattern I stumbled on while trying different algorithms. This textures algorithm uses 2 seeds, so many interesting variations exist. One of the most useful aspects of procedural content generation is its ability to reduce the disk space and download time required by a program. A few lines of code takes a lot less space than several dozen textures, and a few more lines of code takes a lot less space than several dozen models to use in a game. In addition, no computer is capable of holding all of the information needed to build an infinite game world, but some well-built algorithms can generate any data needed with little effort. The game that is known for introducing PCG into the gaming industry is called Elite. Elite was widely considered the first truly three-dimensional game. Therefore, it was the first three-dimensional space simulator. It used procedural content generation to generate the names and important info of each star. The number of stars possible in each of 8 galaxies was constrained to 256 stars by software limitations. Elite is the game that made PCG practical, and its modern successor, Elite Dangerous, shares the same qualities as other modern space simulators. The only hands-on experience in procedural content generation I have had thus far is in texture generation. I am aware of the usefulness of PCG to the space simulator genre, mostly due to watching the development of a game called Limit Theory. For the most part, my knowledge of the capabilities of PCG is limited by what I have seen in this particular game. Other genres of games may use PCG for different purposes not mentioned in this presentation. I would also like to thank Khan Academy for the part it has had in my learning of computer programming. Without their easy-to-use programming environment, coupled with detailed tutorials on computer programming, I probably would not have the skills to create a program that utilizes procedural content generation in a useful, practical way. I expect procedural content generation to continue to revolutionize the gaming industry and to be implemented into other forms of digital media by expanding the graphical capabilities of an ordinary computer and the programming abilities of individual programmers. As I conclude my presentation on the mathematical science of procedural content generation, my hope is that everyone learned something about this valuable skill and enjoyed my presentation.